Okay, welcome to 3-6. The lesson today is going to be about writing linear equation. First thing I want you to do is put this in your notes. When you first write it into your notes, I have to admit that you're probably going to be a little bit confused about it. So I'm not going to really talk a lot about it right now. I want you to make sure that that's in your notes. So press pause, put it in your notes, and then continue with the video. Let's take a look at this example so that you can get a better idea of exactly what they're talking about with the point-slope form. Let's talk about the reason that it is called point-slope form. Okay, so take a look at this problem here. Write an equation in point-slope form for the line that passes through this point and has this slope. And that's the reason that we call it point-slope form. So remember, your generic equation is y minus y1 equals m, which is the slope, times the quantity x minus x1. So all we do is we take these numerals here and place them into the equation. So it's y minus the y value, which is 3, and it's the slope of 4 goes here. And then lastly, it is the x value, so it's x minus, now in this case it's going to be x minus negative 2, so it's going to end up being x plus 2. So let's erase that so that we can see this again. So think of it this way. When you look at your final equation here, this number here is the y value right there. But it's the opposite sign because it's y minus. Okay? And this value here is the x value, but it's the opposite sign. So this is y minus 3, this would be x plus 2, and then the slope, you don't do anything with the sign, we just plug it in. So what I really want you to recognize out of this is that if we didn't have this right here, and we were given the point-slope form of the line, we could say, oh, okay, that line has a point at negative 2, the opposite sign of x, and positive 3, the opposite sign of y. The opposite sign of x right there, the opposite sign of y, and it has a slope of 4. So the power of having a line in point-slope form is that I could take a coordinate plane and say, okay, I'm going to go on the x value, I'm going to go to negative 2, and then up to positive 3, I've got a point right there. And then from that point there, I'm going to rise 4, and I'm going to run 1, and now I can draw that line. That's the whole idea of having a line in point-slope form, so that you can find immediately the point that you're going to start from, and then graph the line using the slope. It's very similar to y equals mx plus b, but in y equals mx plus b, this is on the y-intercept. In this case, we have to find that point somewhere on the coordinate plane using this spot here and this spot here, and in both cases the opposite sign, and then using the slope. Okay, now in problem number 2, they're going to say take that equation that was just given to you, which is this equation right here, y minus 3 equals 4 times the quantity x plus 2, and now turn that into slope-intercept form, the y equals mx plus b form. Okay? So we're going to write that over here. We want to get this into the y equals mx plus b. Okay? So the first thing we have to do is distribute the 4 times the quantity x plus 2. So 4 times x is 4x, 4 times 2 is positive 8. So we've got that part there. Then, once we have this equation here, it's obvious that what we're going to do is add 3 to both sides to get rid of this piece here. So we have a 0 pair here, and we end up with y equals 4x plus 8 plus 3 is 11. So we have y equals 4x plus 11. And that, of course, is in the y equals m, slope of 4, x plus b, 11 would be our y-intercept. Now we can take this and substitute those original coordinates that were given to us, the 3 and the negative 2, and we can do the math. And see that 4 times negative 2 is negative 8 plus 11 is indeed 3, and it checks. Please press pause and do letter A. Okay, once again, there's lots to put into your notes. Please put this section in your notes on writing a linear equation. I want to spend a little bit of time on this and help you see that it is a lot less complicated than you think it is. First of all, this is the point-slope form of a line. We just talked about that. Okay, so from the slope and the y-intercept. So in other words, if they give you the slope and the y-intercept, if you're given the slope and the y-intercept, you're going to want to put that equation in the slope-intercept form. If you're given the slope and a point, you're going to put that the point-slope form. Okay? If you're being asked to write an equation from a graph, then you would find the y-intercept b, and you would find the slope from the graph, and you would do the same thing. So this is really two different ways of putting it into the y equals mx plus b format, whether you're given the slope and the y-intercept, or whether you're given the graph and then you find the slope and the y-intercept. These two here, I want you to see, are just different forms of the same thing here. Notice that we end up with the same equation in each case. In this case, they're saying they're giving you 2 points. So instead of giving you 1 point and the slope, they're giving you 2 points. So what would you do? The first thing you would do is you would do the y2 minus y1 over x2 minus x1, and that would give you the slope. Now that you have the slope, you go back to doing the same thing you were doing up here, and you put one of those 2 points in the equation along with the slope, and you're right back to the point-slope form. If you're given a table, it's the same thing. You use the table in order to calculate the slope, find the slope in both these cases, and then use one of those points combined with the slope in order to create the equation. So this isn't as complicated as it looks when you first look at it. It'll take a little bit of time in order to get efficient with it. So let's put those ideas to work. We're looking here at problem number 3. It asks us to write an equation in point-slope form and slope-intercept form for the line that passes through those 2 points. Now, they gave us 2 points to start with. In this problem here, the first thing they're going to do is we're going to take the 2 points and we're going to use the formula, the slope formula, in order to find the slope. So we're going to do y2, which is right there, minus y1, 9 minus 1, over x2, which is negative 2, minus x1, which is 8. So we get 9 minus 1 is 8, over negative 2 times negative 8 is negative 10, so we end up with a negative 8/10, which simplifies to a negative 4/5. Now I'll use the slope and the coordinates of either point to write the equation. So as you can see here, they use this point, these numbers here, so clearly they're using the first point. Let me erase that so that we can see better. So we're going to use the equation y minus the y value, which is 1, equals the slope, which is negative 4/5, times the quantity x minus the x value, which is 8. So here's our point-slope form of the line. Okay, so here's our point-slope form of the line, and we can use that right here. And I'm going to rewrite this over here because they did not show how they obtain this equation, which I think is very important. We'll start up here. It's y minus 1 equals negative 4/5, our slope, times the quantity x minus 8. So the first thing we should do is distribute the negative 4/5 over x, over the x minus 8. So we're going to have equals negative 4/5, negative there, negative 4/5 x, that's distributing this, and then we need to distribute it here. So a negative times a negative would be positive. Negative times a negative is a positive 32 over 5. So understand, we're multiplying fractions. This would be like 8 over 1. 4 times 8 is 32. 5 times 1 is the 5. And now we're back here at subtract 1 and y minus 1. Okay, so the obvious next step is to add 1 to both sides. So if we add 1, we're going to add it to the constant here. So we're going to have 0 pair. We're going to have y equals negative 4/5 x. Now we could think of 1 as 5 over 5. So 32 plus 5 would be 37/5. 32/5 plus 5/5 would be 37/5, and that's where they get this equation here. So this would be our equation in y equals mx plus b, slope-intercept form, and this right here was our equation in point-slope form. Please press pause and do letters C and D. Okay, let's take a look at problem number 4 example. The cost of assistance dog training sessions is shown in the table. Write an equation in point-slope form to represent the cost of y. Now this is the first thing I would do. They say cost of y, so they're telling you that this is y and this is x, of attending x number of dog trainings. It says find the slope of the line and then use the slope and one of those points to write the equation of the line. So the first thing we're going to do is find the slope. Well, slope in this case is the change in y over the change in x. And the change in y would be this column here, 290 minus 165, which would be 125. Put this here, 125. And the change in x was 5. So it's 125 over 5. That's where these numbers come from. And 125 over 5, you can do that in a calculator, or many of you can see that that equals 25. So we have a slope, m equals 25. So now we can put our points, one of the points, into the point slope form. So we'll put y minus, when we need our y coordinate, which is right here, 165, equals slope, 25, times the quantity, x, minus our x value, which is 5. And right there is where our point slope form of the equation comes from. So the equation of the line is right here, as I wrote here. Please press pause and do letter E.